All right, so today let's look at the topic of decision tree analysis. Let's get started with a quick example. So our example says Jenny Lind. Jenny Lind is a writer of romance novels, and a movie company and a TV network both want exclusive rights to one of her more popular works. If she signs with the network, she will receive a single lump sum. But if she signs with the movie company, the amount she will receive depends on the market response to her movie. So the question is, what should she do? So there are still a few more details that we need, so I'll write those down. There are details of the movie company and their payouts. So the movie company's payouts, they're paying out for a small box office, $200,000. $200,000. We'll say a medium box office. Their payout is $1 million. And for a large box office, their payout will be $3 million. All right, now let's take a look at the TV network. All right, the TV network payout. All right, so for the TV network, they just are going to give a flat rate. So their payout is a flat rate for about $900,000. And then there are the probabilities. All right, so as far as the probabilities, the probability of a small box office, so I'll just abbreviate, small box office is 0.3, right, 30%. The probability of a medium box office, that's given as 0.6, 60%. And then lastly, the probability of a large box office. And that probability is given to us as 0.1, 10%. All right, so here's all of this extra information that is given to us, all of this extra information. So let's go ahead and take a look at what we will need to do as far as our decision tree. All right, so first I'll start off with my decision node, right? In my decision node, I can either go ahead and sign with a movie company, or I can make the decision to sign with the TV network. So signing with the movie company or the TV network is where I'm at with the first decision node. All right, and now I go to my chance node, right? This is decision one and decision two. My chance node, I have a chance node on each one, whether to be with a small box office, medium box office, right? Or even the large box office. All right, so same thing for the TV network. All right, so I could have a small box office, a medium box office, or a large box office. All right, so I want to represent these in a similar way with the same probabilities for each. So the small box office was 0.3. So let's write those in a different color, maybe 0.3. The medium box office was 0.6, 60%, and then 10% for the large. So I label them down here as 0.3, 0.6, and 10%, 0.1, which is 10%. All right. So if we go with the small box office with the movie company, then I'll go ahead and write down these events. I'll just make little triangles for these nodes, these event nodes. All right, so I'll have either $200,000. We said that this would be $1 million, right? And the large box office would pay out 3 million. All right. And with the TV network, I just drew the small box office, medium box office, and the large box office just to do the same thing I did with the movie company. However, we know that we read earlier that the TV network just has a flat rate, right? So for all these same probabilities, I'll have that flat rate of $900,000. All right. Okay, so I need to figure out this expected value, right? This expected value for signing with the movie company or signing with the TV network. So I need to figure out what the EV is here and what it is for this one here. All right, let's take a look at that. So let's change colors. So the expected value for the movie company. So it looks to be 0.3 times the $200,000. And we add that to the next probability, 0.6 times the $1 million. And we add that to that third probability of 0.1 times $3 million, right? This is how we find the expected values. All right, so we multiply each one of these and then add those products together, and we'll get an expected value of $960,000. All right, so we need to take a look at that expected value for the TV company as well. So to me, that looks to be at 0.3 times $900,000, 0.6 times $900,000, and 0.1 times $900,000. All right, and of course, that multiplication and adding those products will give us $900,000. All right, so therefore, using this criteria, then we'll say Jenny should do what? She should select the movie contract. Because it yields to us the higher expected value once we do the math for the decision tree. All right, so decision trees are really good. They're used as visual aids to structure and solve most sequential decision problems. And they're really especially beneficial when the complexity of the problem grows even more. So that's our mini lecture on decision tree analysis. And see you next time. Make sure that you like, share where you need it, and subscribe to the channel. Thanks a lot.